Hi students, welcome to HSC Chemistry and the Chemical Monitoring and Management topic. This is video number 24 on water pollutants. In this particular video, we're just going to have a look at a couple of the basic issues that are associated with pollution in our waterways. And the first and probably the most significant one is associated with heavy metals. Now, heavy metals are broadly defined as those metals with a relative density of 5 or higher, and so probably the most significant one for you to be aware of in this category is lead. There are a number of others, but for our purposes we want to just kind of keep a bit of an eye on this one and maybe track it through a little bit. The reason that lead's important is firstly because it's got such significant negative health effects, particularly linked to brain issues, and so therefore lead in the waterways is a real problem. But also the fact that it comes from such a large range of different sources, so not just from industry but from residential properties, from rubbish dumps, and the fact that things like our lead acid battery that we've been having a look at earlier in this course is a potential source of lead ions in the environment. The effects, as I said, are really significant in terms of brain damage, which has been linked to higher lead levels either in soils or in water. And not just lead, but other heavy metals such as mercury and antimony and a few of those other ones are also ones that are regularly monitored in waterways to ensure that their levels stay under those that have been regarded as safe. Now, of course, because this is about monitoring and management, we need to know how we are going to monitor our levels. So as with many, atomic absorption spectroscopy is a good way for identifying cations. And so as long as we have a light source that's specific to the heavy metal that's being tested, then we can use the technique of atomic absorption spectroscopy. And of course, this has the added advantage of being able to detect cations in very, very small concentrations in parts per million. Flame tests can be something that we can use. We don't tend to use it with something like lead for obvious reasons. We don't want to atomize lead and then breathe that in. That would be very, very dangerous. So we don't tend to use flame testing for specifically lead. But flame testing is basically, if you think about it, as being linked back to the application, specific application in atomic absorption spectroscopy, then it can give you a little bit of a reason why we might do that. Sodium sulfide in solution, which can also be added to highly concentrated acidified or basified or alkalified water samples, can precipitate out those heavy metals as sulfides. So lead sulfide, for example, can come out as a precipitate, and then we can use gravimetric analysis in order to identify that particular substance, depending on, of course, the quantities. If the quantities are still very low, there may be other things like mass spectrometry that we might use in order to try and identify the quantities of lead that we have available. When precipitates are formed in acidified samples, we can identify a number of these heavy metals, not just lead, including silver, mercury, copper, cadmium, and arsenic. And in basified samples, then we get chromium, zinc, iron 3, so the ferric iron, nickel, cobalt, manganese, and aluminium. So this technique is quite a useful one for forming precipitates of a range of metals, ions, including a number of the heavy metals. Okay, not all the ones listed here obviously are heavy metals, but it is a technique that can be used to precipitate a number of different samples. And you will have already started to use some acidified solutions, particularly something like potassium permanganate. Not terribly many examples of basified ones at this point in time, but you will if you continue through in your chemistry courses. The other pollutant that's worth mentioning very briefly is eutrophication. Now, eutrophication is basically excessive plant growth due to high nutrient levels, and that's the key here. What we want is abnormal plant growth, a lot of plant growth, and this most commonly manifests itself as algal blooms, and we see this in some of our waterways, particularly waterways, rivers and streams that are close to agricultural land, where you get a lot of fertilizer runoff. So the main problem that we have with eutrophication is the concentration of nitrates and phosphates being much higher than usual. And these are two substances or two anions that are part of salts that are commonly added in fertilizers. And hence they are such a problem for agricultural land, because if it rains and those additional fertilizers that have been added in order to enrich the growth of plants on the farm then make their way into the waterways, the same thing's going to happen. It's just now we get excessive growth of plants in the waterway rather than on the land. So monitoring the levels of nitrates and phosphates, nitrates obviously a little bit more of a problem because they are all soluble, but we can precipitate the phosphates out in order to identify those levels. But when we see evidence of eutrophication, and you can sometimes see that just with the changing color of the water, we know that these two particular anions are in higher concentrations. There's a number of other potential pollutants of water. We've also looked at earlier in the course things like hard water being linked to higher levels of calcium and magnesium ions, but this just gives you a little bit of an idea of some of the different types of pollutants that may be present in water and what the consequences of those additional ions may be. Thanks for watching.